Hi guys, I'm Vignesh. Now we are going to learn about how to model this complex light bulb designs using of a Solidworks. In this Solidworks, I am going to use a Swaptobos to complete this entire model. Look at it. Here we need to create a plane from this path curve to draw a profile and using of a Swaptobos to create a models. Okay, let's select a front plane to initiate a new sketch from our drawing. Swaptobos is nothing but based on the path curve and profile we can able to draw the entire model itself. First to create a path curve. Using of a styles plane profile only, I am going to create this 2D sketch. So select a styles plane because in styles plane only we have a convert entities. Using of convert entities, we can easy to modify an entire sketch. Okay. So select a styles plane now. Start from a particular point up to its origin itself. Once we prefer this point itself, now I am going to select the vertex points. First one, horizontal constraints. Next is selecting this another vertex point to make it into an collinear constraints. Now choose this endpoint as well as an origin to fix it linear by using a vertical constraint itself. Once it is properly fixed by all this endpoint itself, then we need to fix it by using of a dimensional constraint itself. Okay, so use the smart dimensions. Either we can pick a ordinate dimensions or we can pick a simple of a smart dimensions to fix this entire sketch itself. First, what is the dimensional value is? It is 130 mm. From the center point, what is the vertical dimensions? It is nothing but 140 mm. Once we fix this bottom endpoint, now fix this top endpoint. What is the value of this current sketch profile? It is 250 mm. Now selecting this end as well as an origin point, then fix it with this horizontal dimensions of 250 mm. Okay, let's fix it one by one also. Now just slightly modify the endpoint of this vertex in this particular profile. Selecting this endpoint as well as an origin using a vertical constraints to fix it linear. Also look at the top vertex points. One of the primary point is not fixed completely. It is moved from one end to another end. Using of our dimensions, we can fix this particular point itself. It is easy to constrain the entire profile itself. Now the entire profile is constrained from the vertical dimensions. Okay, just exit the sketch right now. And now we need to draw a profile at the particular origin point because this is a path curve. If you want to create before creating any profiles at the point, first we need to understand which is the exact locations for a profiles which is primarily located in. Because the top endpoint has slightly tilted, the bottom endpoint is fixed within the origin point itself. Look at it. If I just select a right plane and draw a profile and create a Swaptobos body under the path curve, means it is not able to create a proper one at this exact locations. If he needs to create a right one at the right end, means we need to create a proper plane. So select a right plane in this time and choose a bottom endpoint to draw a profile. Now look at the bottom endpoint. Here we can simply choose a 3 sides triangular profile. From the specific center point, let's draw a simple profile at these locations. Once it is drawn, now selecting the center point as well as this endpoint, holding your control button, then using a coincide constraints to fix it. Afterwards, just transfer this line profile into a horizontal constraints. Once it is properly fixed, then using a smart dimensions. Selecting this horizontal line, specify the dimensions itself. What is the dimensions value? It is 130 mm. Once the dimensions is properly specified, it is not a primary profile. Change it into a construction line. By right click, select chain to select the entire line, change it into a construction line because it is only for a reference purpose. The primary profile is drawn now itself. Use the 3-point arc, start from its end point, first point, end point as well as this mid point. Once the profile is drawn, then using a center line from the center point up to its end point, just to specify here its location. Afterwards, what is the dimensions of this value? It is 10 mm. Okay, once the primary profile is fixed, now form a pattern by using of circular sketch pattern. Go to circular sketch pattern. In the entities to pattern, I am going to pick this 3-point arc profile. So select it now. It takes place into a default origin point as the center point. Just to change the location by picking it, drag it up to the particular location itself. Now it takes place into a default positions. Then change the values. Only 3 numbers. Once it is properly specified. Okay. Then look at the corner endpoint. Now we need to convert this corner end to form a fillet. Because it is sharpened, we cannot able to create a proper one at this location itself. So use this corner point, make a fillet by selecting each and every area. Selecting a curve one by one. First one, second one and third one. Once it is properly selected, now the primary profile is created easily. Look at the dimensions of it. The overall dimensions is 130 mm horizontally for the triangular profile and form it by using of a fillet formations. Okay, use this we can able to create a swept boss body. Here we have both the sketch profile as well as a path curve. In the sketch profile section, first pick a triangular profile. Now pick a path curve. Defaultly, it takes at its own positions. The only thing we need to done from this swept boss body means, from the options, look at the follow path. Under a profile twist, select this particular category called specified twist value. Then change the directions into 180 degree because we are going to tilt the complete body under 180 degree of the values. Once it is completely tilted only, the bodies are perfectly oriented. Look at it. Once I change the angle and mode of this particular options, the entire body gets twisted. Entire body gets twisted under the angle. So if you increase the angle based on the parametrical value, the entire body get tilted. The complete body is tilted now. If you want to change the direction, you can also change the direction. Once it is the changes applied, now look at the deviations of it under the twisting parameters under the conditions. How the profiles or changes from one locations to another locations under the profile twist positions. Completely. One by one. Then go to mesh preview and select the thin feature sections. Afterwards, just to change the values. Change the directions of it now. The opposite dimensional category is 5 mm. Once it is properly specified, the perfect body gets created. That is overall the twisted portions as well as the thin feature formations. Now the twisted body is created at the right positions. Using this, we can also create another body at the left hand sections. How we can easily make this? By drawing another profile at left hand sections. Now let's draw another sketch profile at the same kind of a front plane. Show the sketch. Look at it, it is highlighted. Now select a front plane to draw on another profile. Okay, select a front plane and create new sketch. Afterwards, change it into a normal plane. Once it is initiated, using the same kind of a style spline, from the end point, just to draw a profile. Also, we need to maintain a tangential connections on the top end also. Maintain the tangency, then only the perfect body gets created. First is selecting this main vertex point, also the primary curve, use the collinear constraints because we selected only the vertex point. That's why I choose a collinear constraint. Then form a tangential connections at the top end. So selecting both the curve and use the tangency to mate within each other. Once the primary profile gets fixed, we need to slightly constrain each and every endpoint related to the previous curve. First one is on horizontal constraints, fixed it, then selecting the first vertex as well as the second vertex construction line to make it into a polylinear one. Also, we can easy to switch the point from one end to another end. Equal constraints, form an equal constraints at the bottom end portions. Then choose the smart dimensions from the origin, selecting this particular point, then initiating an horizontal dimensions of 250 mm. Once it is mentioned, also look at the top end portions and maintain the vertical dimensional constraint itself. It is nothing but 340 mm. Okay, now selecting this endpoint as well as an origin point and maintain the vertical constraint for the second endpoint also. What is the dimensions of this current condition? It is 130 mm. Almost the curve looks tangentially, also it is fully defined. Using this path curve, we need to create a new sketch profile at the particular faces. Which face it's enough to form a profiles and create a solid body. It is easy to make a perfect one also. Look at the top faces. This faces is enough to create a new sketch, or we can create a plane under that. First, if we select a faces, based on the flip offset, we can able to create a plane. Also, if you only choose a coincide, it is mated with this particular faces itself. We can directly pick a plane and draw a new sketch under that. We can directly select the faces and create a sketch, or you can simply select this particular plane one to create a new sketch also. Because it is a flat one only, we can directly able to draw that. Once we initiate a sketch, select the edges tangentially by right click select tangency and use the convert entities to make it into our current sketch. Once it is initiated, just exit it from this particular sketches itself, because the primary sketch profile is drawn in the faces itself. Using this sketches as well as a path curve, we can able to create a new one. That is, create a new solid body. Hide it. Now go to swept boss and choose this curve. Just selecting this curve, that is a primary sketch profile, and selecting this path curve. Once it is picked at the right portions, now we need to slightly tilt it, relate to this bottom faces itself. How we can easily tilt the entire body at the right proportion means by using of options, follow path, specify twist value. Go to the options, under follow path type, specify twist value and change the angle. What is the angle of that? It is nothing but 180 degree. Same as like how we make the body from the previous one. Look at it, it is connected with each other. That is the exact formations with the right proportions. Also, we need to select a thin features, because what is the thickness of this from this previous one means 5 mm. Maintain the same 5 mm value, then change the directions. It creates a body relate to this previous one. This is how we can simply create a entire body relate to this primary one. Look at it, both the top faces as well as the bottom faces are not tilted. Now let's check whether it is tangentially mated with the bottom one, or we need to slightly adjust the deviations. Look at it, it is not tangentially connected within each other. The connections between that, it is coincided with the endpoint itself. Just try the reverse direction, that is a change into anti-clockwise directions, then look at how it is tangentially made within each other. As this is a perfect one right now. Look at the control between these two solid body. This is how it is exactly controlled with each other. Now check OK. Afterwards, look at the overall deviations of the part. First primary part is twisted. Second primary part is also twisted but tangentially connect within each other. One of the small thing we need to done from here means that is creating a small slot body relate to this primary one. So selecting a right plane and create a new sketch. Then draw a simple slot profile. First we need to show the previous sketch, because from the endpoint only we can able to draw another sketch profile. Once it is highlighted, then use a slot profile and go to this particular endpoint and draw a vertical one. Look at this control of one portion to another portions. Once it is properly fixed, then use the vertical constraints to fix it linear. Now it is maintained within each other. Afterwards, we need to fix it by using of a smart dimensional value also. Also, it is coincided from the center point of this primary profile itself. Now show the path curve also, because we need to position the profiles at the correct endpoint. So selecting this curve, it is already positioned at the curve itself. Then go to hold your control button, selecting this endpoint as well as the slot profile using a coincide constraints to mate within each other. The entire profile is fixed. Then exit the sketch. Using this profile, we can able to create a pocket from the path curve also. Just exit the sketch right now. Afterwards, selecting swept cut and choose this profile. From the sketch profile, I am going to pick the slot profile, and from the path curve, I am going to click this particular path curve itself. Then we need to set the following parameters, which is previously created under the formations of the solid body. Go to options and choose specify twist value. After that, change the parameter value into 180 degree. Then switch the directions. It is currently now in one direction, then change the directions. Okay. Almost controlled with each other. Exit the sketch right now. Now, using the same kind of patterns, we are going to create a pocket at the opposite solid body. Okay. First, we need to turn on the 2D sketch, entire 2D sketch. Go to this particular sketch, show it from the sections, then selecting a faces, or we can straightly choose a plain one to draw a new profile, because we already create a plane on this faces itself. Using this plane, we can able to draw a pocket profile. Now just select this faces and create new sketch. Okay. Show this previous sketch profiles and select this faces and draw a new profile under that. From the center point, draw a primary one. Afterwards, just to fix it, same as like a previous one. Choose both the endpoint of the curve as well as the slot profile using coincide constraints to mate within each other. Also selecting the slot sketches and the point made with by using of coincide constraints. Then exit the sketch right now. Because the profile is drawn already, the path curve is which is previously created one. Exit the sketch. Using this profile and path curve, we can able to create a pocket same as like this previous one. Now just to hide the previous sketch value, using this profile, we can straightly create a pocket. First, select the sketch profiles and the path curve and create a pocket. Also, we need to twist it. So go to options, follow path, profile twist and specify the twist value. Initiate a degree of 180 degree. Then change the angle. Slightly twist this angle. 180 degree only. Then change the directions. If it is in clockwise, we need to change it into anti-clockwise directions. Formed perfectly. This is how we can easily create a Mobius, that is a complex slab design, by using of solid body itself. Only thing we need to done is create a proper profile using this profile form a pocket. Thank you.